Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at Form 1 chemistry. And specifically, we are going to be looking at the topic water and hydrogen. And we are going to look at the reactions of metals with steam. And this lesson is going to form the first part of this subtopic. And in the next lesson, we are going to continue with the subtopic. So previously we talked about the reaction of metals with water, and we were able to compare different metals and how they react with water and also their reactivity with cold water. So today we are going to be looking at two metals specifically, magnesium and aluminium, and how they react with steam. And then we are going to look at some questions. You notice we are not starting with potassium, sodium, or calcium as we did in the previous lesson. The reason why we are not able to do that is because these metals react explosively with steam. So we cannot try that reaction, that is the sodium and potassium with steam. It will be very, very highly explosive. So let's begin the reaction between magnesium and steam. So let's look at what happens when magnesium reacts with steam in the lab. So you start with the procedure. So a small amount of wet sand is put at the bottom of a boiling tube. So it's wet. So there's water that is added to sand, and you'll see why. And then a small piece of magnesium ribbon is cleaned. So we said why we are cleaning is to remove the oxide layer. Remember the oxide layer we discussed in the previous lesson? So it is cleaned and then put in the middle of a combustion tube. And then the magnesium ribbon is heated strongly, and then the wet sand is warmed gently. So we are doing this simultaneously so that we do not affect the reaction. And then the delivery tube, after the reaction is over, the delivery tube is removed before the heating is stopped. So we are going to see why we are removing the delivery tube before heating also is stopped. And then the gas produced is tested using a burning splint. And this is how the setup looked like. You can see the wet sand at the bottom of the boiling tube. We can see the magnesium ribbon, and we can see the delivery tube attached to a gas jar that is placed on a trough containing water. So we usually call this water over water method, like we discussed in the beginning of Form 1 work. So what are some of the observations you notice? So one of the observation is that magnesium burnt the blinding flame. So if you look at the image provided, you can see the brightness of magnesium in the setup. It burns with a very bright blinding flame. And after some time, you notice that the gray, because magnesium that has not reacted is gray in color, it stands to form a white solid. This is because of the formation of magnesium oxide. So the white solid we are talking about is actually the magnesium oxide that has been formed after the reaction has occurred. There's also a colorless gas that is produced in the reaction. When this colorless gas is burnt using a burning splint, it burns with a pop sound. We hear a pop sound. And the moment we hear a pop sound, this confirms that the gas that has been produced is hydrogen gas. So you can see from the image shown, you can see the white product of magnesium oxide, and you can see also the blinding flame. So these are the observations. So three observations. So we see the blinding flame as the reaction is starting, and then the final product, which turns from gray to white. So the final product is white in color, and also a colorless gas is going to be produced. And this colorless gas can be tested using a burning splint. So when a burning splint is used, it burns with a pop sound. So next, let's look at some of the equation for the reaction. So magnesium reacts with steam to form magnesium oxide and hydrogen gas. This is contrary to the reaction of magnesium with water. When magnesium reacted with water, it produced magnesium hydroxide with hydrogen gas. But when it reacts with steam, you can see the product that is being formed is in solid state, unlike before, which we talked about as solution. So this is the word equation, and this is how the chemical equation will be written for this reaction. So next, we are going to look at the reaction of aluminium with steam. We said that today we are going to discuss the reaction of magnesium with steam and aluminium with steam, and then we are also going to compare these two reactions. So first of all, a small amount of wet sand is placed at the bottom of the beaker, boiling tube in this case, and then a piece of aluminium is placed in the middle of the combustion tube or the boiling tube, and then aluminium is gently heated. It's heated strongly. We'll see why aluminium is a bit different with magnesium. Magnesium, we needed to heat it slowly because the reaction happens very quickly because it is exothermic. But for aluminium, it is heated strongly, and then the wet side is also warmed gently. So the delivery tube is removed before heating stops, and the gas produced is tested with a burning spleen. I know we have not yet talked about the delivery tube, but you are going to have a chance to talk about it in this experiment, which we are not able to discuss with magnesium. So first of all, magnesium burns in steam, but the reaction quickly stops. The reason why the reaction quickly stops is because it forms an oxide layer. And you can see from the image, there is this oxide layer that forms on the aluminium. That is one of the uses of aluminium. It's actually used to make cooking pans and pots. Why? Because it forms an oxide layer. This oxide layer prevents the reaction with water, prevents reaction with steam. So the gray solid, that reaction that had already started, will change from gray to white. So you're going to form some white surface on top of the aluminium. So not all the aluminium is going to react, only a small amount because of the oxide layer that is going to form on the metal. And then there was a small evolution of a colorless gas because we said the reaction will start but quickly stop. And this gas also burns with a pop sound. And then the reaction, the gas, however, the production of the gas will stop because we said about the oxide layer. So there is something we discussed on removing the delivery tube before heating stop. So this applies also for the reaction of magnesium with steam. So this delivery tube is usually removed when heating, before heating is stopped. So we continue heating and then we remove the delivery tube. We do not do it the other way around. We do not stop heating, then remove the delivery tube. The reason why you do this is, first of all, when we stop heating and then remove the delivery tube, what is going to happen? There will be a suck back of water. So this water that is in the trough is going to go back into the boiling tube. The reason why this is possible is, remember, in here, the reaction has already occurred. There's a vacuum that has been left. And when this vacuum has been left, if you're not careful, if you stop heating, there's going to be contraction that is going to occur, and then it's going to increase a lot of pressure. This is going to pull water back into the boiling tube. And when the water comes back in the boiling tube, it will cause cracking. And remember, it's very quick because of the change in heat and also the contraction of the apparatus as well. So that suck back is what we are trying to prevent. So we continue heating because when heating is continuing, the apparatus are still in expansion and the gases in the boiling tube are still moving at a high speed. So they are occupying, and the spaces in between are not that they're not that condensed in nature, so there's a lot of vacuum left. So it's a very small vacuum. But the moment we stop heating like this, there's contraction that starts happening, and then that vacuum now is created. This pulls water from the trough. So we do not do that because it's going to cause a suck back, and this suck back will cause the water to come back into the boiling tube, which is still hot, which might cause it to crack. So that same applies when we were discussing on the reaction of magnesium with steam. So let's look at the equations for the reaction of aluminium with steam. So aluminium reacts with steam also to form aluminium oxide and hydrogen gas. Remember, this is the code that stops the reaction from continuing, and the chemical equation will be written in this manner. Do not forget the reactant starts on the left hand and then product on the right hand, and you need to balance your equation. You can see this equation is balanced. Later on in Form 2, you're going to discuss on this further. And let's look at one question. And today we are going to look at a KCSE question in regards to what we have just discussed. So hydrogen, let's look at the question. Hydrogen gas can be prepared by passing steam over heated magnesium ribbon as shown in the figure. So when you look at the figure, we have the wet sand, the magnesium in a boiling tube, which is connected to a tube that goes to the gas jar that is inverted in a water trough. So the first question is write an equation for the reaction that produces hydrogen gas. So basically the first question has asked us to write the equation between magnesium and steam. So the equation is going to be magnesium plus steam, and then we will form magnesium oxide and hydrogen gas is going to be produced. You can go ahead and convert this equation into a chemical equation and balance it. The next question is explain why the delivery tube must be removed from beneath the water before heating is stopped. We have just talked about that. So we said we are removing the delivery tube before heating is stopped to avoid suckback of water, which might crack the boiling tube. The boiling tube. And then the final question is why sodium metal is not suitable for this experiment. So we said as you were beginning this subtopic is we didn't use sodium and potassium unlike before for these reactions. It's because they react explosively with steam. If they were able to react very explosively with water, you can imagine what will happen if you react them with steam. It will be very explosive. So that is the reason why we do not use sodium for this experiment. So that brings us to the end. So next we are going to look at the second part of this subtopic. We are going to look at more metals, reacting them with steam and see what will happen. And then finally, we are going to come up with a reactivity series in regards to the reaction with cold water and steam. So see you in the next lesson.